Mummy on the ancient Egyptian descent of Egyptian DNA. Mummy DNA reveals unexpected findings on ancient Egyptian ancestry. For the first time, scientists have come up with findings from mummy DNA. And after having analyzed the genetics of over 100 mummies, these researchers now believe they can trace their ancestries. As it turns out, they don't have much in common after all with the DNA of modern-day Egyptians. As The Verge related, it was even thought by many that mummies don't preserve any DNA. A previous study was able to counter this, as researchers looked into DNA from 16 royal mummies. That study, however, was ultimately lacking, as the researchers used a technique that wasn't able to accurately tell mummy DNA from modern DNA that could have contaminated the ancient material. What the new study that was published Friday in the journal Nature Communications showcased a new, improved technique for DNA sequencing that allowed scientists to analyze genome data from various Egyptian mummies across multiple time periods. According to Newsweek, the researchers in the new study analyzed DNA from 151 Egyptian mummies from the Abu Zar el-Melek archaeological site along the Nile River, which were preserved from as far back as 1400 BC to as recently as 400 AD. Using the newfangled sequencing technique, they discovered something interesting when looking at the various mummies across multiple eras. The mummy DNA was more similar to that of ancient Near East and Levant residents than it was to the DNA of present-day Egyptians. View image on Twitter. We wanted to test if the conquest of Alexander the Great and other foreign powers has left a genetic imprint on the ancient Egyptian population, said University of Tübingen researcher and lead author Verena Schünemann, as quoted by phys.org. All in all, the study concludes that the arrival of foreign conquerors such as Alexander the Great didn't have the genetic impact on ancient Egyptians that was hinted at on previous studies. It also suggests that ancient Egyptians had a genetic link to residents of present-day Turkey and Europe. The genetics of the Abu Zar el-Melek community did not undergo any major shifts during the 1,300-year time span we studied, suggesting that the population remained genetically relatively unaffected by foreign conquest and rule, said fellow researcher and lead author Alexander Peltzer, also from the University of Tübingen. Additionally, the researchers theorized that, based on the mummy DNA they analyzed, slave trade may have been a variable driving an uptick in gene flow from sub-Saharan Africa to Egypt over the past 1,500 years. Although there were more than 151 preserved mummies analyzed for the purposes of the study, sufficient mummy DNA was only found in 3 of the specimens, Newsweek added. The researchers found a gene in one of the mummies that was connected to lighter skin tone, and more prevalent in Neolithic era Anatolia, establishing a link to people from modern-day Turkey. Mitochondrial mummy DNA, or genetic material found outside the nucleus of a cell and inherited by children from their mothers, was found in another 90 specimens. According to Schünemann, this was a pleasant surprise for the researchers, and proof that the new genetic sequencing methodology could help scientists analyze DNA from wider samples of mummies going forward. We were surprised to observe such good mitochondrial DNA preservation. As mentioned above, scientists have long been concerned about whether ancient mummy DNA from Egypt may be too degraded to accurately analyze due to potential contamination from more modern DNA. Newsweek noted that the researchers made sure that no such contamination would take place in their study, by analyzing the DNA in a clean room, using UV light to treat the mummified parts and remove modern DNA, and scrapping exteriors off of bones to extract genetic material.